Part 6. Proper distance and luminosity distance versus redshift. This log-log graph shows various distances for a galaxy that emitted light in the past, and the light is received by us now with cosmological redshift z, which is the horizontal axis, ranging from 0.01 at the left to 100 at the right. Galaxies close to us are at the lower left. Far from us and long ago is to the right. The distances are all divided by the present Hubble distance, which is 4430 megaparsecs, and the vertical axis ranges from 0.001 at the bottom to 1000 at the top. Our universe is flat or nearly flat, zero curvature. The black dashed horizontal line represents the present Hubble distance. The black dotted curve represents the Hubble distance at the time the light was emitted, smaller in the past. The blue curve is the present proper distance now for the galaxy that emitted the light in the past. For z greater than 1.47, the present proper distance is larger than the Hubble distance. For z greater than 2, the present proper distance is larger than 5340 megaparsecs, and we will never see light emitted after now. The green curve is the proper distance at the time the light was emitted. The curve has a maximum at z equal 1.6, 0.405 times the present Hubble distance, or 1790 megaparsecs. This is the point where the green curve and the black dotted curve cross. For z greater than 1.6, the light was emitted by the galaxy when its proper distance from us at that time was larger than the Hubble distance at that time. But the light has reached us. The green curve is also the angular diameter distance, how far the galaxy seems from the angular diameter measurement of a standard ruler, such as the diameter of the largest galaxy in a supercluster. The galaxy is gravitationally bound, so its diameter is not expanding with the expansion of the universe. For z greater than 1.6, our observed angular diameter for a large distant galaxy increases with z and the galaxy's proper distance from us. The galaxy appears a little larger due to the expansion of the universe. This helps astronomers, but galaxies are not great standard rulers. The red curve is the luminosity distance, how far the galaxy seems from its luminosity and the flux we observe. The luminosity distance is 1 plus z times the present proper distance, and the light is dimmer than simply by distance due to the expansion of the universe. Observing distant early galaxies requires powerful telescopes able to image in the infrared, such as the James Webb Space Telescope. If the first stars began at z equal 50, their luminosity distance is 51 times their present proper distance from us, and their angular diameter distance is 0.02 times their present proper distance from us. The starlight is redshifted by a factor of 50, so infrared. Those first stars are 2,600 times dimmer, and the angular diameter of those galaxies is 51 times larger than if the universe had always been at the present scale factor, and the first stars and galaxies were just like today's stars and galaxies, which is probably false. I hope this information has been useful to you.